Alright guys, this is 12.5 and it's going to begin on page 901. Interpret line graphs. The real world example here says that the table shows the prize money for winners of the Masters tournament. It wants us to fill in the differences between each consecutive year, as well as answering 2 and 3. So go ahead and pause the video now so that you can do that. When you come back, we'll go over the answers. So for your answers, you should have the same numbers that I have over here. Just double check to make sure that yours match mine. They increased the amount of winnings each year, maybe because of economy or maybe more sponsors, whatever the case. Some years they didn't change at all. So number 2 says if the data were plotted, would the points, year and amount form a straight line? And the answer is no, because there's not a constant rate of change. It would end up being a random line that goes up and down. Well, mostly goes up, but not at steady increments. Some of them will be steeper than others. And then when we're doing 0, a line like this would represent 0, where it just goes straight across and then up for the next one. So for instance, if I were to graph something like this, I'd start off with that the 1,170,000's here, and then we go, or right here, and then we go up a little bit to the 1,225,000, then the 1,305,000, and then it's going to stay there for 2 times. So you would have a plateau like that right there. Then we go up to the next number and then plateau again. So we'd have something that looked more like this, not a nice straight line where it's increased in the same amount each year. And then it says the Masters tournament is held once a year. If a line graph is made of the data, will there be any realistic data values between tournament dates? Well, if the tournament is an annual tournament, then there's no amounts between the dates. It's just yearly that these amounts go through. Alright, so making a line graph. It says a line graph is used to show how a set of data changes over a period of time. So to make a line graph, decide on a scale and interval, and then graph pairs of data and draw a line to connect each point. So here they're going to take a step-by-step through making a line plot. It says that, or line graph. It says make a line graph of the data of Earth's population. Describe the change in Earth's population from 1,750 to 2,000. So in 1750 all the way up to year 2000, the population has gone from 790 all the way up to 6,080 million. So step 1 is that we need to figure out how we're going to skip count. Okay, so our skip counting is going to be based on our data. So for a year, I'm skip counting by 50s because that's what they've given me. But if they didn't give it to me in skip counting, then I would need to make it into skip counting. So for example, if they didn't have the 1850, I would still need to put an 1850 there and just leave it blank with no dot. Then with the population, we go from 790 million to 6,080 million. So to be able to do that, we needed to skip count and make it reasonable. So they used us skip counting by thousands so that we could get from 790 up to the 6,000 point without getting crazy. If we were doing hundreds, it would be an amazingly high thing. To be able to go all the way up to 6,000, you'd have a crazy large graph. So let the horizontal axis appear to represent the years, and let the vertical axis represent the population, and then label them as such. And then plot and connect the points, which they've already done for us, and then label and graph with a title. Label the graph with the title. Earth's population has increased drastically from 1750 to 2000. Most specifically from 1950 to the year 2000, there was a huge increase. Otherwise, it was kind of a steady increase, but then it really jumped. So line graphs, the lines in a line graph are used to show the differences between data values and may not show precise values between data points. So it's not like I'm saying that in 1975 there was exactly, I can't even see, there was exactly 4 million or 4,000 million in the population. It's just saying that from 1950 and then to 2000, that's the difference. So we're not talking about a difference between the 2 points, and that's really important for you to understand. With the line graph, it's not giving you the data between points, just the points themselves. And just so you can see the differences. I mean, it's really obvious in this graph. You can really see that these were a steady change, but all of a sudden, in one set of 50 years, it really, really drastically went up. And that's why it's so important to skip count appropriately. So example A says make a line graph of the data. It says describe the change in the number of building permits filed. And let's change these numbers because the book messed up. It should be from 2009 to 2014. And then when we're graphing this, which is something that you need to do first, you need to graph it, you're then going to be able to look at that graph and describe what's happening. So go ahead and pause the video now and plot those points. And we'll talk about the description in just a moment. All right, so here is my graph, and so I've shown that, so now to describe what's happening here is that you'll notice that it's a steady decline. There's a steady decline in building permits being filed in major cities from 2009 to 2014. Maybe the market is getting worse, and so they're not building as much. Maybe they're doing it on the down low and they're not filing what they should be filing. Maybe it's because they stopped building houses for a while since the market got kind of crazy. For whatever reason, though, there was a steady decline from 2009 down to 2014. Interpreting line graphs by observing the upward and downward slant of the lines connecting the points, you can describe trends in the data and predict future events. So that's really what I just did. You know, I noticed that there's a steady decline, so my prediction or my theory is that the housing market really affected it, or that that people started doing illegal work instead of filing the permits. Maybe the permit prices got too high and people are, you know, a little more sketchy with it now. So that was my, that's how I would describe the trend happening. And sometimes you're able to predict the future. Like I would say, if we're looking at this, that I'm going to predict that it's gradually decreasing. So probably by 2016, we're going to be more like 2,000 people or 3,000 people getting permits in major cities. Another thing might be that there's just nowhere else to build in these major cities. Maybe they've completely built up the entire city and there's nowhere else to go, so no need to build. All right, so example number 2 says the line graph below shows the cost of tuition at a college during several years. Describe the trend and then predict how much tuition will cost in 2020. So already you can see by looking at what they did graph here that it's going up, okay? We're definitely in an upward trend. It looks like between every 2 years we're increasing by like $1,000. And so if I were to predict what's going to happen by 2020, I would predict that it's going to go up by 1,000 each time and put us somewhere in the 12,000 area. That would be my prediction. That we were at, you know, about 9,000 or just around 10,000 in 2014, and we had 2, 4, 6 years later. So maybe it'd be 13,000, depending on how you wanted to figure this out. So it's a fairly steady increase, and so by extending the graph, we predict that the tuition would be, and in their case, the book's case, it says 11,500. All right, so you're going to do the same thing for B. You're going to predict the growth of a plant over several weeks and tell us where you think that plant's going to be in 7 weeks, or by week 7, which is right here. And then describe the trend. Is it going up? Is it going down? What's the situation? So pause the video now, and when you come back, we'll go over the answer. All right, so I would say that it's obvious that there's been a steady incline, okay? The plant is steadily growing and getting taller. Steadily, that's an A, steadily growing and getting taller. If I were to predict where it's going to be, how big it will be, it looks like it's growing 2 inches every week now for the past 3 weeks. So I would predict that it would continue to grow and so that by week 7 we would be at 12 inches tall. So I would say it would be about 12 inches tall, because it is growing at a pretty steady increase of 2 inches per week. All right, this is our last example. So it says, what does the graph tell you about the popularity of skateboarding? The graph shows that the skateboard sales have increased. So notice that from 2006, it was 250 skateboards sold, and then when it came up to 2012, it was up to 400 being sold. And so it shows that the popularity, as far as popularity, because this is just sales, but if you're selling more, obviously the popularity is also getting better. So the popularity of the sport is increasing, and the skateboard sales are steadily increasing each year. And you could say it's steadily increasing each year by 50-ish, maybe 40 sold, something like that. 20 to 50 sold more each year. You can be more specific. All right, that's the end of the lesson. And if you have any questions, I'll see you in school. Bye.